Am I audible and visible to everyone? Am I visible and audible to everybody? Guys, can you just respond? Yes, hello everybody. So, yes, welcome to the NEET Byte session. So, I just wanted to tell you, guys, today we are just taking up few questions from the last year of NEET and AIPMT, okay? And let me give my brief introduction, guys. My name is Deepak, and I'm a BTech in Electrical and Electronics. So, I'll be taking up this session for you, okay? So, yes, so let's just start off, guys. Okay. So we do have a question here that was asked in NEET 2017. Okay. So here we do have the acceleration due to gravity at a height of 1 kilometer above the Earth is same as that the depth d below the surface of the Earth. Then which one of the following is correct? So let me just start up. Just a moment. Okay. So guys, we know that the variation of the gravity with respect to the Earth, with respect to the height. Okay, suppose this is Earth. This is Earth. Okay, and this is suppose height h. Just a moment. Okay, we do have a formula for this one, that the gravity at any height h is nothing but g naught. Just a moment. Just a moment, guys. Let me just okay.
ये आवाज कहाँ से आ रही है? कैसे तो आवाज आ रही है?
पता नहीं.
स्पीकर निकाल, ये माइक, ये व्हाइट वाला निकालना.
Okay. Yes, guys, we had some technical issues, so now I'm back. So yes, so just wanted to tell you that the gravity at any point, or you can say at any height h, so that would be equals to g naught, that is the gravity at the surface of the Earth, okay, and r upon r plus h whole square. Okay, and we do have the gravity for the surface means at the depth, that you can say here as g naught 1 minus d upon r. But here you can see that we do have 1 kilometer. The range is only 1 kilometer. Okay, so that is not, the height is not comparable to the radius of the Earth. So we need to use this formula that gh is equals to g naught 1 minus 2h upon r. Okay, so here they have told us like the gravity at the both the point is same. So what we are going to do is we are just going to equate both the things. Okay, so here the height is given as 1 kilometer here. So you need to just figure it out at which depth the gravity would be same at the height at 1 kilometer. So this is gd is equals to gh. Okay, h is nothing but 1 kilometer, right? Just a moment, guys. So gd is g naught 1 minus d upon r, and here this is g naught 1 minus 2h upon r, and h is given as 1 kilometer. So g naught will get cancelled out here. 1 minus d upon r is equals to 1 minus 2 upon r, right? So 1 will get cancelled out here as well. Minus will get cancelled out. R will get cancelled out as well. So d is coming out to be 2 kilometers. Just a moment. Okay. So this is one of the basic question. Means this is very pretty simple, guys, right? Everybody is like able to solve it, I guess. Okay, so this is the, guys, just give me a moment. Okay, so this is the first solution here. I guess everybody must have understood this one, right? So anybody who didn't get this one, anybody who has like problem of understanding this one, I guess it's pretty clear with everyone, right? So I mean, see, in the NEET, like you will find not, big questions, to be frank, but you just need to put the, like, the right brain at the right time. That's all. Means you just need to figure out what is the, like, important part in that, where just you need to put, the right things. That's all. So another question we do have. Okay, so here you can see, we do have a graphs. Four graphs is given to us. So starting from the center of the earth, having the radius r, the variation of the g, you just need to predict the variation of the gravity with respect to the depth. Okay, with respect to the depth inside the earth. So I guess everybody knows about this one, that at the center of the earth, at the center of the earth, the gravity would become zero. Means we do have a weightlessness condition, right? Everybody must be knowing about this. And you know that we do have a formula like in this way, that I have already told you in the first slide, that g at any depth is equals to g naught 1 minus d upon r. So if you are at the center of the earth, right, so d will become r. So gravity at that point will become zero, right? Everybody knows about it, right? So but we need to just figure it out, which one of the graph is correct here, right? So I just wanted to tell you one thing, guys, which all the graph are starting from the zero, because at the depth we do have the gravity exactly at zero. So this one, and this one, and this one. So a, c, d are starting from the zero, but whether it's a linear, parabolic, hyperbolic, we don't know, right? So what we are going to do, we need to figure it out, how the gravity varies with the depth. Okay, let me just take it on this board here. Okay, so I do have a formula here, just a moment. I do have a formula here, that is g, no, sorry, g dash is equals to g naught 1 minus d upon r, right? And here I'm going to make this earth, okay? And here you can see this is, suppose, the depth d. But you can see in the graph, we are starting it from the center of the earth, right? So suppose if my variable is, suppose, x, suppose this variable is x here. So you can see that it is starting from the zero, because in the graph I am just starting from the x, not with respect to the d, right? So x will coming out to be r minus d, isn't it? Right? So if I put it, the gravity formula in this, so g naught 1 minus, this is r minus. So just a moment, here you need to put d, right? So this would be r minus d. So this is x, right? So d will be coming out to be r minus x, right? So what I have to put it, r minus x instead of d, right? So this is the one, and g dash is coming out to be 1 minus 1 plus x upon r, right? 1 will get cancelled out from here, and you can see that we do have a gravity relation that is linear with the distance, isn't it? Right? So how can we just figure it out, this one? We can just build up a small graph here till the point r, right? And that would be nothing but the linear, right, till the point r, right? So that would be linear. It won't be a parabola or something like something else, okay? And after the r, how the variation of the gravity with respect to the height, you know pretty well, that is g dash is equals to g naught r upon r plus h whole square. You can see that everything is constant here except the h, and g dash is nothing but inversely proportional to the h square. So that is nothing but the parabolic, right? So after that, it will be decreasing like in this way. So which option should be correct, guys? The D option, right? So here it is, the D option, right? Is that clear with everybody? Right, guys? Okay. So now we are taking up one more question here. At what height from the surface of Earth, the gravitational potential at the value of G are minus 5.4 into 10 power 7 and 6 meter per second square? Means they have given us the value of gravity at that much of height, okay, and they have given us the gravitational potential at that particular distance, okay. You just need to figure it out, the height, at what height it is being happen, okay. So what I'm going to do is, you know what is the value of gravitational potential? That is minus gm upon r, or you can just write it in this way as well, minus gm upon r plus h is equals to minus 5.4 into 10 power 7, right? And they have given us the value of gravity as well, right? So what you can do is, you can just, minus will get cancelled out, guys, okay. So gm upon r plus h, okay. So what you can do is, they have given the value of gravity at that point, right? And what is the value of gravity at that point? You know pretty well. This is, you just multiply with r plus h, both the denominator and numerator. So this will remain same, and this is the thing, guys, okay. And this value, you can see here, this value is already given to you, and that is nothing but the 6 meter per second square, right? So r plus h is equals to 5.4 into 10 power 7, right? So what you can do is, you can just calculate, this is 0.9, this is r plus h is equals to 0.9 into 10 power 7, okay. And here r is already, you know that, that is 6400 kilometers plus h, and this value is in the meters, right? So how can you just make it? This is, I can write it in this way, isn't it? And this is 9000 minus 6400, and h is coming out to be, just a moment, yeah, this one. So height, you can see here, at 2600 kilometers, the gravitational potential and the gravitational potential and the gravity will become in this way, okay. So guys, you can see that, I mean, this is not like, you know, kind of a goose chase here, like, it's not a very very difficult questions we do have. You just need to just put the small formulas, and you just need to derive it. You just need to figure it out how to, you know, make it in a proper way. That's all, okay. Fine. So another question, guys, like, I guess I'm gonna take up this last question here, so then we'll wind it up. So guys, we do have a satellite having a mass m, and it is orbiting the earth of radius r here, and at a height h from its surface. The total energy of the satellite in terms of the g naught, the value of the acceleration due to the gravity at earth's surface is, okay. So let me just make a small illustrations for all of you to make the things better. So this one is like earth, okay, just a moment, okay. And here, this one is h, and this one is r. So I'm just going to make it this distance, you know, that r, and this one is h, okay. So here we do have a satellite having a mass m, and it is being revolved around the earth, okay. So yes, so here the value of the gravity is g naught, and we need to just express the total energy of the satellite in terms of the gravity that is at the surface of the earth, okay. So first I need to figure it out, what are the terms, what is the total energy of a satellite? It is nothing but the potential energy plus kinetic energy, isn't it? Can you just tell me, what would be the velocity, what would be the velocity of a satellite that is being revolved around the earth? That what you have to do is, you just need to do the centripetal force and the gravitational force are being, the gravitational force is providing the centripetal force, the necessary centripetal force. So what I can put it here, that is mv square upon r, okay, is equals to gmm upon r square. So here this r will get cancelled out and m will get cancelled out, and the velocity, the orbital velocity, will come out as under root gm upon r, right? So if I just wanted to write the total energy here, what it would be? The total energy would be sum of the potential as well as the kinetic that I have already told you. So here you know that the potential energy would be negative, and that is minus gm m upon r, plus half mv square, right? Half m, what is the orbital velocity? V square. If you just put it like in this way, gm upon r, so it would give you minus gmm upon r plus gmm upon 2r. So the total energy is coming out to be minus gmm upon 2r. Is that right? Okay. So this is the total energy, guys. We just need to represent it in the form of g naught and all that, right? So how we are going to do it? Okay, so the total energy is coming out to be minus gmm upon 2r, right? And r is the total distance, that is like radius of the earth and the height. Okay, so r is nothing but this. Okay, so what I can do here is minus gmm upon 2. This is, I am going to write it in this way. Okay, and what I can do is I can just divide and multiply with the r square here. Okay, so what I'm going to get, you can see here, this complete thing gm upon r square is nothing but the g naught, isn't it? So the total energy is coming out to be minus g naught m r square upon 2r plus h, right? Right, this is the one that we are getting here, right? So that's all, guys, means this is the one. So I guess we do have an option here. See this one. So this is the total energy. This is how we are going to represent, in this form. That's all, right? So that's all, guys. We have taken like questions here. And so yes, that's all, guys, from my side. Okay, and thank you for attending the session, and for more details you guys can just check the links here. Okay, thank you so much, guys. Bye bye, take care.